The question is that show that the ratio of sum of first n terms of GP to the sum of terms from n plus 1th to 2nth term to 2nth term is r 1 over r ratio 1 over r raised to the power n, right? We have to prove that. Now if you will see, basically you have to show the ratio of sum of sum of n terms of GP to the sum of n plus 1th to 2nth will be equals to 1 over r raised to the power n. This we have to prove. Basically, we have to find out the right hand side. Now, if you will see that the GP is the same, it is the same sequence. From the same sequence, they have collected some n terms from the starting. And after that, after collecting these terms from the same GP, they have collected some other n terms from that GP only, and they have find out the ratio. So this is the numerator and this is the denominator, right? So now if you will see, first of all, understand what is a GP. So GP is a sequence in which you have the common ratio. Like suppose I will say 2, 4, 8, 16 and so on. So this is a GP because if I will divide the two consecutive terms, the second term over the first term, 4 over 2, you will get 2. When you will divide the next two terms, 8 by 4, you will get 2. When you divide 16 by 8, you will get 2. Here, the ratio is coming the same. Okay, the quotient is coming the same. So this is the common ratio. So that is a GP. Okay, now let's talk about the numerator. Sum of n terms of GP. There is a particular formula to find out the sum of n terms of GP, that is sum of n terms of GP. Sn is equals to first term, always whenever we have a GP general, so first term will take as A times R raised to the power, R is the common ratio, and because it is the same GP, so the ratio is also the same. Okay, so R raised to the power n minus 1. Oh, sorry, wait a minute. R raised to the power, in bracket we will write r raised to the power n minus 1 over r minus 1. This is a general formula to find out the sum of n terms of GP. Now we collected the numerator. So numerator we have through the formula only. Now we have to work out for the denominator, where we have the sum of n plus 1th term to 2nth term. Now, if we will see the denominator, so we have collected some terms which starts from n plus 1 and finish up till 2n. So when we write the general sequence from n plus 1, so the first term for these terms, it will be a of n plus 1, then second term will be a of n plus 2, then third term will be a of n plus 3, and the last term will be a of 2n. Okay, so this is the sequence. But when we have to write the particular term, suppose we have to write for, let's say, just a second, we have to write the general formula for the particular term. So if you see the general formula for writing any term, that is an is equals to a times r raised to the power n minus 1. So if we have to write the formula for a n plus 1, it will be a times r raised to the power n plus 1 minus 1. Similarly for n plus 2, a times r raised to the power n plus 2 minus 1. Similarly, a times r raised to the power n plus 3 minus 1. Similarly, the last term will be a times r raised to the power 2n minus 1. Okay, so you will see 1 cancel out with 1, 2 minus 1 is 1. So what will be the GP here? What will be the GP, the terms, collection of terms from n plus 1 to 2n nth term? It will be a times r raised to the power n, only n is left with the as the power, then a r raised to the power n plus 1, then a times r raised to the power n plus 2, and a times r raised to the power 2n minus 1, right? So this is the number of terms of the second sequence that we have collected. Okay, so first term for these number of terms is this one, a times r raised to the power n. So if we have to find out the sum for these terms, so sum from n plus 1th to 2nth term, that will be equals to a, the first term, which is a times r raised to the power n. Now we don't know how many terms are there. So whenever we don't know how many terms are there, so we can say that we have n number of terms, right? So a times A is this one. R raised to the power, because we have collected all the terms from the same GP. So R is the common ratio, which is R only, raised to the power N, which we don't know how many terms are there, N, minus 1 over R minus 1. Okay, so this is the sum for n plus 1 to 2nth term. Now we have to find out the ratio. Okay, now we have the numerator, we have the denominator. So when we will divide the numerator over the denominator, you will see that sum of n terms of AP and sum of n terms of, not AP, GP, sum of n terms of GP over sum from n plus 1th term to 2nth term. That is equals to, what is this? A times this one over, for this it is A times R is to the power N. We put this formula, R minus 1 over R minus 1. So this cancel out with this cancel out with this, A cancel out with this. So what is left? 1 over R is to the power N. Okay, so this is the final answer. Okay, so yes, thank you everyone. Thank you so much.